This question is a rather bizarre question because there's so much to sort through. There is this table up top, there's a description of what it shows, there is a graph, and then there's a question. And so I will do what we usually do, which is to analyze the graph, Oizerga. So our origin is at 0, 0, force and time, our x and y axes. So any questions about force and time we would read. The gradient is the rate of change in force. And the area is F delta t, which is the impulse by definition. And the change in momentum is m delta v. And of course, because the impulse is what brings about the change in momentum, the two are quantitatively equal to each other. So if we read the question, it just asks, during which interval of time does the magnitude of the momentum change the most? Well, change in momentum is the area. So which one has the biggest area is this question. And if we look at this, so here is 004, 003, 002, 001. So 0 to 02 is this time interval. So which has more, that one or 4 to 6? 4 to 6 is there. Eight to 10 is over here. And this change of momentum is the same for each time interval listed as false. So we can see that if we're just quickly scanning this question, it looks like this is choice B, because it's asking the magnitude of the momentum changing the most, and that's going to be the area. So now let's go and see if it's really this easy, this question. So we got the data table, and we draw out the scenario. So X travels on a horizontal surface. So here is X when it has an MO, constant speed in the positive horizontal direction. So we have that right. Cart X collides with Y, also of mass with M0. Notice these two are different from each other. So it's a larger mass, which was initially at rest. So then afterward, Y has a positive velocity. So Y is moving in that direction. Immediately after the collision, X and a Y could have one of three final velocities indicated in the table. So the total momentum of the system is the same before and after the collision. So the one possibility is that X stops and Y moves off with Vy1. The other possibility is that X has a velocity, and so does Y. And the third possibility is that X is moving in the other direction and Y is moving in the positive direction. The momentum is conserved all along. So given that scenario and reading the question, it turns out we don't need any of this information above to answer the question number 7. Now, maybe this is part of a multi-question task, but we didn't actually need to examine that initial information at all.